Hello and welcome to a new video. My name is Herwig Juster and today we discuss 3 considerations for optimal dimensional stability of plastic parts after processing. Okay, let us get started. So when you think of polymer-based parts, they have dimensional stability which is not equal to that of metals. And the dimension stability can vary with several factors, which we'll discuss now in the following in more detail. So if it is a critical part where dimensional stability plays a key role, this needs to be considered during the polymer material selection process as well. Okay, let us get started. The first consideration is residual moisture and moisture uptake during use. So as a general rule of thumb, you can say that materials which are exposed to moisture, it is likely that dimensional changes will occur. So for example, in case your application has tight tolerance requirements, polymer with low moisture absorption should be taken. For example, an aliphatic polyamide such as PA66 was specified for an application with tight tolerances. However, due to the moisture uptake during the use phase, the part performance decreased and a replacement material is needed. In such a case, a semi-aromatic polyacrylamide, a para, can be an alternative since it has the lowest moisture uptake of all polyamides. There are also other polymers such as a polyetamide, a PPS or a polyether ketone, which have excellent mechanical and also moisture performance. When you think of PPS and also PPA and also polyetamide, they can be used for application which are exposed to high temperature and also moisture during the use itself of the applications. So you can think of water pumps in cars, for example. And so when we now take a step back from the use phase and right after or before processing the material, the polymer, there are also certain maximum moisture levels allowed before processing to not harm the polymer during processing. And the different maximum moisture levels that you can get from the material supplier of the material you want to process. Okay, the second consideration is mechanical strength. So in case of structural application, the loading strength of the selected polymer is important and can influence the dimensional stability. So for a complete evaluation of your part, you need short-term property data such as the tensile strength and the compression strength, together with long-term data such as tensile creep. So the tensile creep data give you really a feeling how the material is changing after a certain period at certain temperatures. And what are some examples of high performance polymers which show high dimensional stability? These are, for example, PPS, a polyamide imide, and also a polyether ketone. And the third consideration is thermal stability. So a temperature load can have a severe impact on the plastic part dimension. Therefore, it is critical that you evaluate the maximum use temperature. And also how long this maximum is occurring, and the continuous use temperature. Always in combination with the environment. So if the part is in air, hot air, or water glycol. And for evaluation of the temperature impact, dynamic mechanical analysis, or DMA for short, is useful, as well as, for example, heat deflection data, HDD. Okay, so these were now 3 factors. Overall, there are some more factors which we already also discussed in previous videos, but those are the top 3: moisture, mechanical, thermal, which you should keep in mind when dealing with dimensional stability of polymer-based parts. Okay, if you want to have more information on polymer engineering topics, I highly recommend you my blog fundamentalplastics.com, as well as my online courses on polymer material selection. I will link you both the blog and the courses in the description below. Okay, I would like to thank you for watching, and do not forget to subscribe and smash that like button. Till next time, bye!